All right, guys, it's 10 o'clock here in the Netherlands where I'm based, and it's time to start. So welcome everyone for yet another webinar in our case studies webinar series. My name is Vincent van Beuzenkom. I'm CTO at technologycatalog.com. I'll be the host for today's webinar. I'm happy that I'm joined today by Ole Vatne from Aker BP and Evan Solsvik from FourPhase. And actually quite a exciting case study, if I or my take on it, that you will be presenting today, because you're actually addressing two very hot topics in our community. One being sand or solids management, and the other being remote operations. And yeah, you managed to merge the two in this case study. So I think many people will be very interested to hear more about this project and be able to learn from it. Before I hand over to you guys, just a practical note for the folks joining us online. We will pick up the questions at the end of the session, but at any time you can already just post your questions in the chat, and then we will pick them up at the end after the presentation. We'll have about 30 minutes of presentation, and then 15 minutes for Q&A at the end. So having said that, I would like hand over the floor to you guys, and look forward to this presentation.
Right. Good morning. Everyone who's experienced sand in their shoes knows a little bit is okay for a while. A lot over time is a pain in the ass. Same goes for oil and gas. A little bit is okay. But what do you do when it starts filling your shoes or production separators?
Right. Short presentation of me and Evan. So I'm Ole Vatne. I work as a senior intervention engineer in Aker BP, primarily on the Valhall field, where I plan coil tubing, wireline, flowback, solid management, pumping operations, etc.
My name is Evan Solsvik. I work as a product manager in FourPhase. Started FourPhase about 10 years ago as an offshore operator, and later progressed to shift supervisor before moving onshore about 5 years ago, and started planning offshore operations. So today we'll present a industry-first remote solids management project in the North Sea, a collaboration between FourPhase and Equinor, where we did a pilot and we delivered.
Okay, bit on the Aker BP strategy. So the aim for Aker BP is to become the leading E&P company. And to succeed with this, transformation is needed, basically. And what the strategy is, that one of them, of course, are to aim to make decisions faster, better, and more collaborative across all disciplines working onshore, offshore. And to do this, we have a cloud-first infrastructure, scalable, secure platforms that enables real-time collaboration and data sharing. And of course, when we are in execution, we are making decisions based on data and no feelings. So for the point that you see here, like the future operation. So for the future, we are planning for more collaborations between all parties working for Aker BP, and we are planning for remote operations where we can, and to utilize the optimum PUB offshore. And of course, this will also take down the emissions offshore. The future is more remote operations, autonomous operations, and reduced offshore exposure. If you can move on to the next one, Evan. And this is a site over the one of the new field on Valhall, Yggdrasil. So Aker BP has a large portfolio with small platforms where we have low PUB capacity, both for the new fields that we are developing, but also on the old fields. So, and for all the future work we are planning on this will be with the same strategy with the low PUB capacity. And we will be shuttling, we will be walk-to-work vessel on normally unmanned installations and unmanned installations. And we have small platforms with little PUB capacities. And the new fields will be operated, remote operated CCR, which will control the NUIs and the platforms and the subsea pipelines. So this means, as you can see, that we are planning for remote operations for the future. And on Valhall field, where we did this pilot job, it's the same setup. We have a central platform, and we have a lot of small NUIs, normally unmanned installations. So with very limited PUB. So we need to optimize the PUB offshore. Do the next one, Evan. And how will Aker BP do this? So we have Aker BP has invested in Gnist, a new building in Stavanger, which is built for the future. This will enable remote operations and collaboration between offshore and onshore. And within this new building, we have integrated operation centers with the secure data center. And it's a centralized hubs for monitoring and control and reducing the offshore footprints. And by doing this, we are allowing operations and close cooperations between onshore and offshore. And as the previous slide with Yggdrasil, it will be controlled from Gnist, the control room, with a minimum PUB offshore. So Gnist is technical setup for all this. Within intervention, we also have our own secure integrated offshore center, which we have installed the FourPhase equipment to do this remote operation. Data-driven decisions are key. And before we used radios, telephones, and so on. Now we have IDEX, which is a data platform, gathering all data into one dashboard, and with all parties working for Aker BP, they have access to this data at all times. So it's very easy to speak the same language and monitor operations from onshore to offshore. For this specific Valhall IP operation we did, we understood that FourPhase had the technology already in the portfolio to perform remote operations. And we triggered on this, and we did screening in-house to see if we're able to do this. So, and together with FourPhase, and we utilized the Aker BP project team internally, the Gnist, the new building project team, and the data security team, and we set up the office spaces within Gnist for FourPhase within the IOC. So FourPhase had their own office space with CCTV, radio communication directly from onshore to offshore with the crew offshore. And they had a secure data hub to remote operate their equipment. As you know, this was a pilot, and we did a lot of risk assessments going to come to this point where we ended up doing this pilot. We had full PUB for the first time offshore. So we had 2 guys on both nights and days, and we had a very experienced guy onshore day and night. But the whole aim was that FourPhase were doing the remote operations from onshore, which we succeeded on. And by investing in this, we are planning for the future on other operations together with FourPhase to reducing the PUB and optimizing the crew offshore and operations. Because we have a big portfolio with projects going on, so we need every bed space we can get. All right, then I think you can move on, Evan.
Right, thanks, Ola. We started preparing for remote operation years ago. We saw how the industry was shifting. We delivered our first autonomous D-sander in Asia 2018, which set the foundation for remote capabilities. In 2022, we delivered our first remote monitoring operation. So this was a normally unmanned installation which had no personnel on the night shift. So we had the client control room and monitoring our equipment. We shifted our focus to Aker BP. Coordination became critical for success. We worked side by side with their operation planners and risk assessed the scope to make sure every part of the operation could be executed remotely and safely. Over quite some time, it took a lot of planning and testing from both Aker BP and FourPhase to finally set on a pilot on Valhall IP. Took a lot of resources to design equipment that could operate offshore equipment from 250 kilometers away safely and secure. Aker BP informed us that they had similar remote scope with Halliburton, controlling offshore equipment from Stavanger. So we had our location. Aker BP had new facilities, GNIST, under construction, where we can set up our remote control equipment in a dedicated office at GNIST. To make sure this would work, we used Aker BP's existing point-to-point communication concept. This is a secure line, which has been used for other remote operations, like Halliburton cementing. So rather than reinventing the wheel, we could simply use a similar setup for solids management. Who is FourPhase? So we're a small Norwegian company with main offices in Bergen. We deliver projects globally, desanding equipment and other flowback equipment. We have offices in Houston, and Malaysia, and Azerbaijan. We're very proud to have 99.9% uptime across almost 200,000 hours of operation. And over the years, we've become a full flowback provider. It all started out with a desander, and we saw that different clients had different needs. So we expanded the portfolio with choke manifolds, multi-phase meterings. It would be storage vessels, degassers, and filtering systems for the oil and gas industry. As the name implies, FourPhase handles the fourth phase of a production stream. We're separating the solids from the other three phases: oil, water, and gas. We're using cyclonic separation concept to handle the solids, similar how to a Dyson vacuum works. And this is the foundation of our company, FourPhase. We were planned to show a small animation here, but it unfortunately not work. So here we have a cut view of a standard desander skid. It consists of two separate vessels with a vortex maker inside, using the cyclonic concept to separate heavier particles from the carrier fluid. And it's all collected in an internal bucket with a state-of-the-art weighing system. So we'll get the online readings of all the solids that's captured in physical weight. We have a wide variety of operations that we do, everything from flowing a live well and separating the solids to handling the solids after it's reached the production facility with a separator jetting operation. We can, of course, use the same solids handling equipment for intervention work, like coil tubing operations. We can do a lot of solids. We've seen a lot of it, different types and different challenges, epoxy, steel, rust, reservoir sand, millables. Basically anything that is heavier than the carrier fluid, we can separate with cyclonic separation. We've also made tailor-made solutions for particles that's not heavier than the carrier fluid, floating, which for example is rubber, where we had to utilize a filter solution. We're very proud to present how compact our equipment is compared to our competitors. We're focused in on having the equipment modular, really small footprint to facilitate a lot of operations. We see that deck space is a limitation on operations, so we took our step and created stackable systems with a 2x2 meter footprint to make sure we can handle a lot of different challenges regarding workspace available. So yeah, this is not to scale, but we can see an example here of how compact the FourPhase dual flow is with other descending equipment from similar or from other vendors that's supplying the same type of technology. So focusing on the automation and what makes this feasible as a remote operation, we've got one PLC controlling everything in the dual flow, a common computer that reads and analyzes all the data and maintains integrity and operates our valves. We have pneumatically operated valves that's controlled with software and solenoid switches with a programmed interlock sequence, which avoids all manual labor in flushing, choke operation. It's all automated and sequential driven. Keeps the unit sealed up and limits exposure to harmful substances. On the hardware side, we have pressure monitoring, we have temperature monitoring, we have weight reading, as mentioned, live data review, valve positions, and flow rates on all the 3 phases. On the software side, we have soft sensors that's monitoring all the different valve cycles and can predict maintenance, and we can be ahead of time with expected wear and tear on the equipment. Calculates the pressure cycles, differential pressures for optimum efficiency, and everything talks together through the same channel. All data is real time. So put it all in context, here we have an example of a full coil tubing cleanout setup with a full layout, taking returns to production separator. So this is our closed loop setup where we take the coil tubing returns directly from to the dual flow unit before it goes into the production separator to ensure that we have clean returns during coil tubing intervention operations. By doing it this way, we can avoid any atmospheric contact with the well fluids. Everything is sealed and monitored and automated. So this closed loop setup gives us a safer alternative to, for example, a shaker, where you have atmospheric exposure of your pressurized fluids in return. So eliminating the exposure risk for the offshore crew, which is very important for us. Moving on to the case study and how we delivered on Valhall IP. We were quite limited on deck space since we were multiple wells being worked on at the same time. So flexibility and compact footprint were key. This layout showed how we planned our rig up on hatch deck, using a donor well, routing returns directly back to the production separator. So the flow path on this illustration here would be coil tubing returns coming up through the riser with the valves going through our surface safety valve, following the desander for solids removal. Clean returns went to the choke manifold, which is stacked in this illustration, before we went to a multi-phase meter to give Aker BP all the 3 different phases to monitor the return rates prior to entering the donor well and back to the production system. Closed loop setup with full monitoring on solids, oil, water, and gas. Also, a major point in how we could make this remotely operated using our observer. This is a unit that we deliver that gathers all the production data and all the data from our system continuously, building a solid database with more than 170 operations to this date. Various operations and customers have decision based on facts, like Ole mentioned, and not on assumptions. So this is our stage on getting all the different data to make high quality decisions. The observer can talk 300 different languages and is made as a data collection point. It can collect data from client sensors, our own sensors, other vendors that we're delivering equipment together with. It all is being collected in the same unit. It's stored locally, but it's also transmitted to cloud. So how everything is data streamed onshore is really proud to show this, and it makes us improve in operation planning and execution. If you lose the cloud-based services, everything will be stored locally as a contingency, so we can extract the data at a later stage to take learnings. So for the pilot on Valhall IP, as Ole mentioned, we had a full offshore crew. How we had them offshore as a full POB, as a contingency, just in case anything were not going as planned on the onshore remote control part. So we call it a hybrid operation, where we focused on the learnings and controlling it from onshore, while the offshore guys were present as a contingency. It was operated from Gnist, and we had our direct line from the offshore equipment, two-way communication to Gnist using Aker BP's secure lines. Parallel with this, we share data from offshore directly to Stimline to facilitate IDEX data management. So going forward, the plan is to take away the contingency team offshore and go over to 2 POB, 1 per shift, monitoring the equipment and focusing on the hands-on operations like rig rounds, skip handling, and maintenance, while the remote supervisor at the Aker BP office is controlling the descending sequence, operating the choke, and setting up the multi-phase metering. So that means that it's a more efficient setup with less POB and a better integration between operations and data collection, as the onshore supervisor can focus on the data part of things. So a bit messy, but this is a block diagram on how the system was set up for this pilot. The blue boxes indicates the offshore equipment that's outside in the field where we had the different units, the multi-phase meter, dual flow and choke, communicating with the brain box and into our local control station, where we had a separate line going to the onshore control room in Stavanger, Gnist, and also local control stations, observer, and transmission to the cloud. From our control room in Stavanger, we had fully operational overview, direct radio and phone contact with the guys offshore, access to live production data, and even camera feeds from offshore to actually monitor the equipment. We're sitting right next to the Aker BP intervention planning team, so communication was instant. We could follow the operation in real time and react quickly to any inputs or changes. So this really showed what's possible. So this operation was fully controlled from onshore, and for upcoming projects will be positioned even closer to the Aker BP planning team, actually sharing a room with them instead of having a separate FourPhase control room, which makes this even better for how we think it's going to be. This is an illustration of how we actually delivered on this pilot compared to our planning, and we're very proud to show that our full returns handling package fitted within 4 by 8 meters, and it's all fully sealed. So full management with choke, dual flow, and multi-phase metering with that small footprint, and it really showcases how we can do things, and with the good planning that we can be flexible and modular. So for results, we're very happy that we made this work. It was operated safely with no exposure, and we can focus on our learnings and improvement of our processes on how to do this for the future. But we know it's feasible. We've done the pilot, and we are focused on this is the future for operations with Aker BP, and we need to progress together. So overall, very good experience, a lot of learning, and very happy. Over to you, Ola.
Thank you, Evan. So, of course, this was a good operation, but of course there are a lot of learnings. Can you guys hear me, Evan?
Yeah, I can hear you. Yeah.
Okay. I just got that screen. All right. So basically, the guys sitting onshore here was very linked up to the FourPhase crew offshore, but we did not succeed to integrate them fully into the coiled tubing crew, also the entire intervention crew, which we know for the future. We need to focusing more on integrating them with the offshore crew, so they are all as one team. They were a bit set on the side here, so that will be something we need to do. We know from this project, similar projects for the future, we need to start quite early. It's quite a lot of planning to get things like this done. Because there are so many stakeholders. There are facilities, data security, so and onshore, offshore support. There's a lot, and also to even succeed with this. So we as a E&P company needs to be flexible and wanting to do this, and we also need suppliers to have the same mindset. We need to be flexible, and we need to work together to get things like this done. We had planned for this, but for the future as well, we need to do the same. Very experienced, so some of the most experienced offshore personnel needs to be sitting in the onshore chair and operate the system. So we need to have that know-how from the guys, from the experienced people. The new building now, the first pilot now, we were moving into it, so we had just moved in. Basically, we were sitting in the drilling IOC. Now the intervention IOC is fully open, and the next time will be even closer together. So that will be good. And also, with this new way of working, if we're going to succeed, we need close collaborations between the companies, the unions, and all the workers offshore, onshore to succeed in this. So I guess that was the key takeaways that we had. Overall, a very good operation, which we succeeded on. We can move on. Evan?
Yeah, I think we're ready for the Q&A.
Excellent timing, guys. Well done. So this leaves sufficient time for the Q&A, and good to see that the questions have started to come in. So what I will do, I will read out the questions. That's also to the benefit of those that may watch the recording later that would otherwise not be able to see the questions. And for those of you that joined late, just know that if you have any questions for Ole or for Evan, just type them in the Q&A, and we'll pick them up here from the chat. So I'll leave it up to the two of you to decide who's best placed to answer. And let me start with the first question from Daniel, who said, could you please give some insight to what is monitored to execute your predictive maintenance strategy? This was a question that came in already earlier on during the presentation.
Yeah, to answer that, so to predict valve maintenance, we monitor valve travel times. So when it goes from fully open to fully closed, we know how it should be, and we can trend if the valve timing, operating time is increasing. That's indicating that we have more friction on the gate valve surfaces, and it should require greasing or a replacement or a rebuild. And we can also see with the sensors how much differential pressure is being held over the valve before it cycles to see if it's any potential wear or high loads actuated on that valve. And we have timers which is actually decreasing online, doing calculations with the travel time to see when we should do maintenance and give input to that. It also uses air pressure on the actuator to see how, if it's higher air pressure than normal, it would be shorter travel time than normal. So it's using that kind of data, yeah. Mm.
Right, yeah, thanks. I think that hopefully that answers your question, Daniel. Then the next question, also quite an interesting one. How many field engineers do you require on site? Or is it also manageable with the standard rig crew on site only? So I guess indeed you described maybe here you were a bit, you had some extra precautions. But how do you see this to the future as well?
So for a normal setup with a dual flow choke and a multi-phase meter, we have guys field without taking consideration the remote scope. It's a lot of data management and keeping everything on track, online calibration of the multi-phase meter. And of course we have brakes, so we need relief in those brakes. So it's normal 2 guys per shift. We have equipment that is, we have operations that we can have 1 guy per shift, but that's typically we have an agreement with the client that they can assist us and monitor and actually be some hands on deck if we need a rig around and stuff like that, and we can limit the POB in that way. If it's a high solids load operation, we would have 2 guys per shift, but in more production operators with lower sand rates and less maintenance on equipment, we can go down to 1 per shift and have a an agreement with the client. As per now, we don't have client-operated equipment, but we have training programs that we have done to have them as a good source of assistance.
All right, thanks. Next question is about the communication and the safeguarding around that. So what is your mitigation plan in the event you lose communication between the operation center and offshore during the operation? What are the safeguards to avoid such situation?
So for Aker BP operations, if we lose the communication from onshore to offshore, we will still have manned equipment, but we are undermanned compared to what we should have done. Or should have been with 2 guys, 1 guy operating choke and 1 doing management. So we will work. It would not be a stop in the operation since we have the 1 guy offshore. Together with Aker BP, we work as 1 team, and the coil tubing guys and the production guys are familiar with our equipment, and we can get assistance from them. So we are covered if we lose communication from the onshore facilities. We still have everything set up offshore to take local control in case it needs to be.
I can add in that, and also in worst case, we would get, if we were on coil, we'll get to a safe depth and then stop the operation and the clean out basically when we are safe, if we need to fix it, if the guys offshore can't manage it. So.
Okay, clear. And perhaps linked to that, there's a question: how do you manage a sudden slug flow of solids? And actually, this links to a question I had, and maybe you can blend that in. Is that what do you actually do with the solids management itself? And is that any different compared to the conventional way now that you run this as a remote operation?
So solid slugs, of course, it's harder to separate 100% once we have the high concentration of solid slugs, but we can take 800 kilos an hour. Usually we plan along with the coil tubing operations team to slow down the pull out of hole speed if we are lifting up the solids on the wiper trips. For normal production jobs, we usually don't have these kind of solids rates that's overloading our equipment. For the solids handling part, it's very similar to how other cyclonic systems works. We would isolate the vessel we would flush and flush it to either open skips. It could be closed skips with a lid on it with venting to safe area if there is a risk of hydrocarbons coming in returns, or we can flush to cuttings reinjection if the platform has a drilling facility and online injection solids injectivity for waste disposal. So that's the major types of solids handling that we do. But it's very similar to how other vendors do it, from the unit to the solids management side outside the unit.
I can also add in that we are planning to not be too greedy and take big slugs of solids so that we can manage them. But if they come, then we can bypass the cyclone. We always prepare production to, if we get too much, we need to send some solids their way, even though we are trying to take out all solids to protect the production facilities. But in worst case, we will have to send it past the cyclone.
Thanks. Next question is actually slightly different, but not less interesting. And this very much relates also to the remote operational aspect. How do you see that, or how do you see the future of jobs offshore in the sector? What do you feel are the key skill gaps that you will face as the sector will roll out this type of automation? Perhaps this also links to the remote operation part.
I guess you still need to have the same experienced personnel, right? So we will, PUB-wise, to operate this, we will be the same. So 2 guys offshore, 2 guys onshore. Today, without remote, we are 4 guys offshore, 2 on each shift. And we can't operate this right as it is now without experienced crew. Of course, automation will make it easier, so we don't have human errors and such on. But we are just removing some jobs onshore instead of offshore. But there are other projects ongoing. So when we shuttle over to these newies or the platforms, we are fully booked PUB-wise. So it is very crowded offshore.
So our ambition in FourPhase is that all the equipment is controlled from onshore, either Aker BP or at our offices in Bergen, and then we have maintenance crews traveling offshore to the different facilities and overlooking the equipment. That would be more applicable for production operations with lower solids handling rates and equipment wear compared to the intervention work that we are doing together with Aker BP.
And I guess for the automation bit, automation, what it makes us, it will make us more predictable every time. If we do the same every time, then there's no room for, as I said, human errors or different ways of doing it. It will be the same. So we can plan accordingly, time-wise and operational-wise. So that's the big upside.
Yeah, I can see that. Next question is actually quite practical and takes us back a little bit to what you shared earlier around the timeline, but then a bit more detail. How long did it take from the time when FourPhase advocated the concept to Aker BP to the time the pilot project was executed? And particularly, the person had a question about the business case approval process. Was it quick or very tedious? And what's the decision scale in terms of the investment that was required to run this project?
So the leads with Aker BP is actually it is a few years ago that we actually started looking into this, that it's possible, but we really got traction on it. You have to correct me if I'm wrong, Ola, but I would say January or around New Year's time last year, where we started focusing in on finding a pilot operation where this can be done. So that was the main target, was to set a operation and deadline for when we should deliver and have this set up for a specific planned operation. For investment costs, FourPhase have been planning towards this for a long time. So everything was mostly in place, automation level and communication setup. We just had to perform some final client-specific setups for the Aker BP office, and of course spend time on testing that. And a lot of resources went in with the Aker BP IT security team. And of course, Aker BP had the benefit of less PUB offshore, or not for this pilot, but for the future. So they spent resources on that for the future operations, where we limit the personnel exposure and personnel offshore. But as this was a industry, the industry is working towards this, it was easy to have at least the FourPhase managers accept this as of course, a risk and an investment opportunity to adjust and facilitate for more operations and more tighter collaboration with Aker BP. As Ole mentioned, Aker BP is especially challenged on the personnel capabilities on the different normally unmanned rigs. So we needed to take actions to still be a part of the operations that we do with them.
I guess we had it was more or less half a year ahead before we started. But we had started it. We had set up the project teams internally here to investigate if it was something we were gonna move forward. And we saw that the technology was ready. Aker BP facilities were ready. The team here were ready. So it was actually quite a smooth project to get through, and we were ready quite early. But of course, we took some time. We started people onshore earlier than we normally would have done, just to check that everything was working, communication. So we had some days, almost a week ahead before we started, to make sure that all the communications, we test run the equipment and so on. So yeah, it was a quite smooth project, basically.
Well done, guys. Yeah, that's quite a impressive timeline for such an industry first, and maybe also a very nice one to wrap up the Q&A, because I see we've reached the end of this webinar. If people now want to know more what the opportunities are for their own operations, whether it's for these type of cleanouts or other solid management projects, I would recommend them just to contact Evan and the team and see what the opportunities are building on this. I think, yeah, for now, Ole, Evan, any closing words before we wrap up the session?
I guess this shows that with a good collaboration and the right mindset and the right setup, facility-wise, and also for the vendor, then a motor operated equipment can be run safely. Of course, you have to risk it, but overall, a very, very good first-time pilot, I would say. It worked, basically. So we're all happy.
Great. Evan, anything to add to that?
No, I'm just really glad that we managed to do this pilot, and with the learnings we have, and getting shifted towards a remotely operated future. So it's going to be exciting, and the industry is transitioning, and it's very good to be a part of it. And we have Aker BP as a strong client to collaborate with. So very happy for that. Mm-hmm.
Great. So thanks again for presenting this with the community today. This is actually going to be our last webinar of this year. I'm going to wish everyone a very nice festive season for the weeks to come. We'll be back with a new series of webinar early in 2026. And yeah, we hope to see many of you in these sessions again, sharing learnings and drive technology deployment. So thanks, and see you next time. Bye-bye.